In this video 5.3, we are going to be looking at slope-intercept form. By the end of the video and work time in class, you should be able to say, I can write and graph equations with slope-intercept form. A parent function, and all of the functions we will be looking at the remainder of the year, is the simplest function in a group of functions with common characteristics. For a linear function, the parent function is y equals x, or f of x equals x. So on my coordinate plane here, if I was going to graph the parent function y equals x using my blue marker, y equals x looks like this. That would be y equals x, the parent function. Now what we're going to do is we're going to be manipulating this parent function. So for example, if I was going to graph y equals 2x, it's going to look like this green line. This would be y equals 2x, where I've changed the slope. We see the rate of change has increased. If I wanted to, I could do something. My points are just a little off on this graph. The markers aren't lining up perfect. But then I could graph something like this red line. It's supposed to be a line. There's not supposed to be a curve there. And this would be something like y equals negative 1/2 x. I've manipulated, again, the blue line. I've been flipping it so it has a negative slope, and that slope is negative 1/2. So the blue line is the parent function, and we're going to be looking at common characteristics that blue line has with lines like the green one and the red one. A linear equation is an equation that models a linear function. The variables cannot be raised to a power other than 1. Graphs of linear functions may cross the y-axis at any point. A y-intercept of a graph is the y-coordinate of a point where the graph crosses the y-axis. So if we look at this coordinate plane here, and if I wanted to graph something like this line here, it should be a straight line. There's a linear function. Now if we look here, the y-intercept is at 0 because it crosses at the origin where the y-coordinate would be 0. If I graph another line using my green marker, let's say something like here, if I look at this linear function and we see where it's crossing the y-axis is at 0, -3, so the y-intercept is at -3. When we're working with linear functions, we have a slope-intercept form that can be used. It's called y equals mx plus b, and it is of a linear equation of a non-vertical line. So this is one way to represent a linear equation, y equals mx plus b, where the m is the slope of your line and the b is your y-intercept, where that line crosses the y-axis. So what is the slope and the y-intercept of the graph y equals 3x minus 6? Well, the slope is 3. The y-intercept is at -6 because we see the minus in front of the 6. That makes it a -6 for the y-intercept. What is the equation of a line with a slope 5 and a y-intercept of 8, y equals 5x plus 8 would be the equation in slope-intercept form. On this graph, I'm going to move this here. I'm going to graph a line. I'm going to change that here. And so we're going to look at this line. So we have the blue line. Okay. And we're going to write the equation of the line in slope-intercept form. So we need to find the slope, and we need to find the y-intercept. The slope, if we look over here, from one point to the other, rise 3, run 1. Rise 3, run 1. Rise 3, run 1. Rise 3, run 1. We see it's a positive slope. It's going upward from left to right. We rise 3. We want run 1, not 2. So the slope is going to be 3. And then the y-intercept, we look at where it crosses the y-axis at 0, -2. So the y-intercept is -2. So we have our slope of 3. We see our y-intercept at -2. So it'd be y equals the slope times x, and then -2 because it's -2. If it was a positive 2, you'd write +2. What is an equation in slope-intercept form of a line that passes through the points 1, -6, and -310? Well, on this one, we would start by finding the slope using our change in y over change in x. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1, 16 divided by -4 gives us a slope of -4. So we have y equals -4, which is the slope, times x, and then we still have to figure out our y-intercept. So we can plug in a point in for the x and y. We've got 2 points up here. You can pick either point, plug it into this equation. I'm going to choose 1, -6. So in 1, -6, the y is -6, -4 times the x, which is 1, plus b. We simplify, and then we solve for b. So the b isolated is -2. And so in slope-intercept form, the slope is -4 times x minus 2, which is your y-intercept. What is the graph of 1/2 x minus 1? Now that we know what slope-intercept form is, it's kind of like a nice shortcut. We don't have to make a chart of inputs and outputs of different ordered pairs. I look right away at my y-intercept. Start there. It's at -1. The slope from there is at 1/2. Rise 1, run 2. So from where the y-intercept is, I have at 1 point already. I'm going to, from the y-intercept, rise 1, run 2. Rise 1, run 2. Rise 1, run 2 to the right. This gives us a positive 1/2 slope, or -1, -2. Connect these these points to make your line. And there's your linear equation. That's your graph of y equals 1/2 x minus 1. A carpenter charges $45 plus a fee of $30 per hour for labor. We're going to write an equation to model the total cost of a job. What graph models the total cost? So if I make some values here, we have, let's see, 0 is at 0 hours, it would be $40.05 just for your fee after 1 hour, 75, 2 hours, 105, 3 hours. We just keep adding $30 every hour. So our equation, the total cost is 45 initially plus 30 per hour. I could change the order of that to put it in slope-intercept form. So my slope is 30 and the y-intercept would be 45. So I'm going to change my interval. On the bottom, I'm just going to go 0, 2, 4, 6, 8, 10, 12 for the hours on the bottom. So this is our time. And then on the side is going to be the cost in dollars. And for that one, I'm going to go up by 50s. So 100, 200, 300, 400, 500. So at 0 hours, it's $45. Oh, that's going to have to go down a little bit. We're just right below the 50. And then at 1 hour, if we look at that table, 75. Oh, that's at 2. So 1 hour would be right there. At 2 hours, it's about 105. 3 hours, it's 135. So we're right about in here. At 4 hours, it would be 165. So right about in here. And then it would, whoa, that line is not, my marker is off on the smartboard here. We see the line and it would continue to increase from there. Can you say I can write and graph equations with slope-intercept form? Write a summary and reflection and be prepared for the work time in class.